Hello everybody, let's start solving day 6 of Element of Code. So today we're going to work with a guard. So we're transported to some kind of point in the past and we have to understand where the guard that's guarding the lab is going to go ahead of time so we can search safely. So we are given a map of a starting situation and the position of the guard is marked by this this character. It's facing up from the perspective of the map and obstructions are marked as hashtag. And now we are going to, so the rules for the guard is that if there's something in front of him, he turns right, and otherwise he goes forward, just forward. So he basically just like goes until he hits something, then turns to right and moves forward. So he walks like that until he leaves the mapped area, which means walking past the bounds of the map. And our goal is to determine which specific positions will be stepped on by the guard, including the starting position. And now, how many of those are there? Okay, so that's basically we can simulate the movement of the guard as long as the input is not as huge as and it seems pretty reasonable. So I think it should be fine to just simulate what's happening there. Just let him walk through the map and just wait for it to go outside of the map, because this is very, very small area, so it cannot take too long for it to walk through. So let's save the input. I will save the input here, and we will start solving this. So let me open my solution. Here we go. So, first order of business, let's close everything that's not needed. So I need day 6 here. So I prepared already the empty class. So what I will do is to first read in the map itself. So I will do some width height, and now we will read in the input. So while reader await input reader read line async is line. So while we have some input, we will just read in the line. So width will be equal to line length. That's going to be always the same, and we'll increase the height. And now we'll just create a private car. Create a private car map. That's going to be our map, and we'll put, if it's not null yet. Oh, we don't know the height yet. So yeah, that's not correct. So we'll have the list of string lines, and we will just add the line there. So lines, add line. So now we read it in, then we set the map to new instance, then we read in the lines where x is the width, lines y, yeah, okay, so that seems okay. So now we read in and you have the map, and then we need to simulate the movement. So actually what we can do is to see if, so position point, it's gonna be our 2D point, starting point, private point, starting action, or actually we can just leave it like this, and we will do a method that will take care of it. So starting point, so we read in the starting points, which will be if the map point is equal to this character, we'll read the starting point and set it. And now we can do a method that will be count steps. Yeah, that's pretty good. Steps, start, and we will just let the guard walk. And what we will need to track the steps that we already encountered, starting point, is to have, so this is going to be the result, so we can actually return this to string. So what we'll do is we'll have a hash set of point, which will be the visited points on the map, and we'll let the guard walk through them. So let me just increase the font size here. So we will start the current direction. Current direction is pointing upwards, which means x0 and y -1. And now we'll let the guard walk. So while point x greater or equal to 0, and basically we just we ensure that we are within the bounds of our map, and if we're not, we walked out of the map, we just return the number of visited locations. And now we have to do the walking itself. So now we're standing on a specific point. We add that point to our hash set. Now we have a next point position, which will be walking in that current direction, and we have to check if next position is greater than equal to 0, and next position. Okay. Oh, right. So we can actually do it like this. We can do while true, and if next position is less than 0, or next position y is less than 0, or next position x is greater than width or equal to width, or next position y is greater than equal to height. In that case, we break. So this will be our condition for breaking. But if the position is valid, if it's actually on the map, you'll check if else. If map next position. Actually, let's take this, and all right, not like that, no, but it can be extracted is valid position. So this is just extracting the logic to check if the position is valid. So position like this. So if the next position is valid, if it's not valid, so if it's out of bounds, okay, if it's out of bounds, so This is checking if the position is not within the map. Then we break. If the next position, next position y equals 2, and that's the character is hashtag, then we have to rotate to the right. So rotate, turn right. So that means we'll have to adjust our current direction to be turned to the right. And how do we turn to the right? So if we are pointing upwards, then turning to the right will mean new point. We'll have to the right. It means that we'll have to do minus y and x, and that should be hopefully correct. So if I am going to right, it's 1 0, and turning to the right should be 0 1. Yeah, that seems it should be working fine. So this should rotate me to the right, and now the next position will be different. And again, if the next position is out of bounds, next position, then we break. But otherwise, we continue, add it to the next, and just try the next position. Maybe it would be possible to write this cleaner, but it should be hopefully enough. And I think that's it, unless I'm missing something. So, but we will see quite quickly. So I'll just take the test data here. Put it here, and let's see what happens when I launch this. So we are day 6 now. If we run it against the test data, we are getting into some infinite loop, of course. Classic situation. So what happened there? Okay, we crashed completely even. That's unexpected. So let's see what happens there. So our current initial starting point is 4 6, and that should be 4 and 6. Yeah, that's okay. So we walking through the next position. So next position, current direction. Oh, I'm not, of course, it's a classic mistake. I didn't update the actual loop variable, so current position, current point equals next position, because I didn't update it. I was always standing on the same location, which was completely useless. So now 41 is my result here, and that seems to be fitting the input. So let's try with the big input. So let's see what happens there. 4,758. And that is correct. All right, so that marks the end of part 1. Let's do part 2. In part 2, we need to find a way to limit the petrol area of the guard so that we can safely search the lab without getting caught. We should be able to add a single obstruction that will get the guard stuck in a loop. And we need to know all possible positions for such an obstruction to be added. Okay, so we basically need to add a obstruction. That means that the guard will keep walking in a loop repeatedly. So something like this. That is interesting. So how do we do that? Essentially, we need to find all the positions on his initial path that we calculated here, where we can cut off that path and change it. So essentially, so far, what we have calculated is 4,000 positions where the guard will walk. And in any of those positions, the next position in the sequence can become an obstruction. And that obstruction should, and we need to understand if putting that obstruction there will mean that we will get into a loop. So how do we do that? So we will need to change this quite significantly. So I will just copy for now what we have into part 2. And now let's consider our options. So we no longer need to count the steps. But we need to have positions for the obstruction. And those are exactly those which are found during this initial walk. So I can actually, what I can do is just return visited. Because this hash set is exactly what we need there. Now, so we have potential obstruction positions from the starting point. Now, what we need to do is to have a new method that walks through the map and remembers not only where the guard already was, but also in which direction he was facing when he was walking there. So, because if we come to the same position but facing a different direction, it's not the same thing. It's only the same thing when we are already walking in the same direction as we walked before, which means that we are in a loop. We can actually cross the same point twice, but in a different direction. And that means a different result. So, does guard loop? If we take a point, starting point, start, end point, new obstruction. So our directions here, there are 4 directions. So what we could do is to give those indices weight and make it so that we track it as integer and use like a Right, so how do we do this? Yeah, okay, so we can we can actually, let's do it simply. We can do visited point direction, because it's gonna be that huge, so we can actually track it like this. Visited. So now this will mark not only the position but also the direction where the guard was facing. So current direction, current point, and then we do actually we can take most of this we can take. And now we have to add current point plus also current direction as visited. Now, yeah, or rather, if visited contains already current point and current direction, then we return true because we loop. And if we don't end up there, then false. So we have a kind of bug. Yeah, because we don't call this, right? So return does guard loop starting point and okay, so for each potential obstruction and potential obstruction, we will, if it loops, then we just add that position. We just counting, right? We are how many different positions? Yes. So we will count position, obstruction count. We'll just increase obstruction count plus plus, and then finally return obstruction count to string. All right. So that's it. Now we will be walking, and if we visited the same spot with the same direction, we are done because we are looping. Otherwise, we just walk. We just walk as if it was normal, except for if next position x equals new obstruction x and next position y equals new obstruction y. So there is an additional condition. We are hitting existing obstruction or a new obstruction that we added. Both of these occasions turn us to the right. So that's it. So we turn to right, we have the next position, and we update the current point. I think that's it. So hopefully, if I didn't make some mistake in judgment, this could be working. So we'll put test input. Is it test input is the same as in the previous one, right? Yeah. So let's do part 2 with this data, and we have 6 positions. 6 different positions. Yes, that's promising. So let's try this. And it's 1586. It took a while, but it's not too bad because it's still reasonable. Oh, it's too low. Okay. Huh. I don't think so. It's just accidentally the same thing. But yeah, so I missed some position there. It's too low. Okay, so there's more looping that's possible. So what can be the difference there? What did I miss? So if it's one problem that I see now is that I cannot put the obstruction on the starting position itself. So that's one thing. So except starting point itself, or remove. No, I am the except. Well, I mean, yeah, I can do it here actually. So except starting point. So that's one thing, but that will not increase the number of loops for sure. That cannot increase the number of loops. So what is the problem there? Actually, I can use the new notation there. So what am I missing here? So could it be that the potential obstructions are not necessarily on that path that the guard was walking through? Like for the guard to hit the obstruction, he must have walked through that point during his initial walk. Otherwise, it doesn't make any sense, right? So we added a new obstruction. Exposition is... Okay, let's try to run it like this, but this couldn't have worked, right? It's with the input file. 15,000, yeah, so that's not right, right? We did that exactly. What was the number? Yes, that's right. So it's the same number. So it doesn't, it cannot be right, but it's too low number. So the next position must be oh, am I making a big mistake here? Because I'm not when I change the direction, I'm not saving that into the visited location list. So that's a big problem, I think. Actually, I shouldn't be walking there either, in either case. So this means that I update just the direction, but keep the next position will be just current point for now. We'll store that with the direction and then we continue. Not sure if that's the problem, but no, it's so now it's getting 0 there. That is weird. What is the issue there? So it means that we never loop. For 5. So I made a mistake there. So once more. We're standing on a point. We want to go in the direction. There is an obstruction that's blocking our movement. So we change our direction, stay on the same position, and we continue at the next point, next position. The next position is what is that? That is weird. I think I made a mistake that I didn't want to do there, but it doesn't count correctly anymore, and it's counting very, very low numbers. Which is wrong. So how many visited locations do I get here with the test data? We get 12 visited direct locations. So the guard, well, this is already wrong. So the change caused us to visit less locations. So if I leave it like this, it will be still 41, right? So what is the difference? So when I moved in the direction, why do I have to move in the direction? If I keep this like this, it stops working. Oh, I know it doesn't. I completely omitted this line. That's why. That explains it. Okay. All right. So let's try now with this one, and that's better. That's a different number. And the reason is I wasn't storing that direction for the current point where we rotated ourselves to the right, and that's probably, hopefully, it. And it is. Okay. So that was a bit of a stumble, but we have solved day 6 of Advent of Code 2024. So I will go back to calendar. 7th day is coming soon, but I will still also make another video which you can see on my channel, which will be ChatGPT trying to tackle this problem. We will see if it handles it or not. So see you tomorrow.